Certain things have certain properties, and here are the ones that you need to know. The two big ones are what's called the commutative property. Somewhere along the line I started calling it the commutative. I guess I'm wrong. Commutative. Make sure I spell it right. Commutative property. And the other one we're going to look at probably a little bit more in depth than the others is the associative property. Commutative property, associative property. Have we talked about these before? Probably not. Now, in order for you to remember these, which I would very much like you to do, it's probably best that you kind of break apart the words because they give you a little clue as to what that thing is. For example, the commutative property, the root word of that would be this word right here, which is commute. Does anybody know what the word commute means? Gabby's taking a shot at it. It's to move. Did that come from the book? Did you get that on your own? Did you see it somewhere? I like it because that's exactly what I was hoping you would say. To move. Your parents probably commute to work. Sometimes the question would be, do you have a long commute? Does it take you a long time to move? And that's the key to the commutative or commutative property. It means that numbers have moved. For example, this. If I take 6 plus 3 and I move them around, flip-flop their places, and I write 3 plus 6, that is still the same answer, correct? 3 plus 6 is the same as 6 plus 3. Even though the numbers have moved, it's still the same answer. That is the commutative property. And you're going to say, duh? Somebody say, duh.
No.
But see, this isn't, the commutative property doesn't work for everything. I cannot do this with subtraction. I can't say that 6 minus 3 is the same thing as 3 minus 6 because it is not. 6 minus 3 is 3. 3 minus 6 is negative 3. Okay? The commutative property only works with addition and multiplication because 6 times 2 is the same thing as 2 times 6. So you have the commutative property of addition and multiplication, but it doesn't work with subtraction, nor does it work with division, because 18 divided by 3, which is 6, is not the same thing as 3 divided by 18. By the way, what is 3 divided by 18? Okay. 3 divided by 18 is, Gabby? It is not a negative number, by the way. If you have $3 and you divide it among 18 people, 3 divided by 18, oh, we're going to struggle this year. Sam Poppin?
60 cents.
No, you're still dividing 18 by 3, I think. 3 divided by 18. 3 divided by 18 is actually a fraction, which is what?
1/6.
1/6.
That's 60 cents, right?
No, 1/6 is not 60 cents. 1/6 is not even an even. It's like 16.6 cents. Repeater, 6 cents. Okay? So please know, the commutative property works only for multiplication. It only works for addition. Okay? It's something that you've used forever. You just never really thought about it, especially when we did problems like this. 8 plus 6 plus 4 plus 2. You were taught from a very young age to use this commutative property because when you add up this long list of numbers, what did your teacher always tell you to do? Look for groups of 10, which mean in essence what you're doing is you're moving these numbers around. I took the 8 and added the 2 to it first, and then I took the 6 and added the 4 to it first. I got 10 here and I got 10 there, and I ended up with my 20. You can't do that with subtraction. You can't take 20 minus 6 minus 4 minus whatever, 10, and rearrange it and subtract in different orders, or plus 10 or whatever, and get the right answer. Okay, so that's the commutative property. And please note, because you're going to have to be able to tell the difference between these two, in the commutative property, the numbers move. They change places. Because the associative property is different. The associative property, ladies and gentlemen, comes from the word associate. And here's kind of a little stretch, but you can figure out, what does it mean to associate? You know, if I ask you who you associate with, Kyle, it's to hang around with. Who do you hang around with? Who do you gather with? And this is an example of the associative property. If I have, let's say 6 times 4 times 5, and I put a parenthesis around this, that's the same thing as if I have, 6 times 4 times 5, parenthesis around other ones. Okay? In the associative property, the numbers don't move. That would be the commutative property or commutative property. In the associative property, you have to have parentheses, and the ones that you associate together change. Okay? I will get the same answer for each of those. If I take 24 times 5, I'm going to get 120. If I take 4 times 5, I get 20 times 6, I get 120. So when you're asked to tell which property it is, you need to look for this. In the associative property, the numbers will be in the same order. The only thing that changes is the parentheses. In the commutative property, commutative property, the numbers actually are in different orders. They move. And it's a little tough, but you got to get used to it. Okay? Could I have parentheses with the commutative property? Yes. I could have this. Take a look at this. 6 plus 5 plus 3, and I put a parenthesis around this. And if that equals 6 plus 3 plus 5, okay, that is not the associative property. That is just the commutative property, because the only thing that has changed is these numbers have flip-flop places. The associative property, the numbers have to stay in the same order. It's only how they're grouped that changes. In this one here, the only thing I did is I changed the places of between the 5. Told you this would be exciting, didn't I? Did I not say this would be exciting? Yes, I did say this would be exciting. Got that? Because we got a couple more. These are the big ones. These are probably the ones that people get more confused with than the other ones. The other properties, still under properties, are called the identity property. The identity property, and the identity property is, you have it for both addition and for multiplication. The identity property is what happens, or how do you get the same thing you started with? How do you get the same thing you started with? Let me give you the, for example there. Let's say I'm talking about addition. If I'm talking about addition, if I start off with an 8 and I add something to 8, what is it that I always add to a number to get the same number I started with? I know it's hard, Taylor.
0.
Exactly. 8 plus 0 equals 8. This is the identity property of addition. The identity property of addition is just when you add 0 to it, you get the same number. Okay? Not to be confused with the identity property of multiplication. If I have 12, I don't multiply 12 by 0 to get 12. I multiply 12 by, Grace, 1. Okay, so in the identity property of multiplication, you multiply by 1. Here, you add 0. And by the way, it doesn't have to be a number, it could be a letter. I could say b plus 0 equals b. If I asked you to tell me what property that is, you would just say that's the identity property of addition. That's all it's going to be. Huh? Or if you did this, if you did mx times 1 equals mx, and I asked you what property that is, you would just tell me that is the identity property of multiplication because it's multiplied. Don't worry, math gets much harder than this. And there's only one more property. Only one more. And you'll be able to figure this out just by the title of it. What is the 0 property of multiplication? Thinking about this, if you take 32 and multiply it by 0, you are going to get 0. If you take A, B, C times 0, you're going to get 0. So henceforth and hitherto, the 0 property of multiplication is just simply says that 0 times anything is 0. 0 times anything is 0. Zero times nothing is 0. Perfect. Hold on just a second here. Lest we get too caught